Welcome to the third problem-based tutorial. In our previous session, we made some important measurements. In this tutorial, we will take additional measurements on the same circuit, that is, the half-wave diode rectifier. Problem statement: perform the following tests while simulating a half-wave diode rectifier circuit. Number 1. Use the multimeter block to measure the circuit current and the voltage across the load resistance. Number 2. Use the measuring port of the diode block to measure the maximum reverse voltage, also called the peak inverse voltage of the diode. This parameter helps us verify whether the diode remains within its reverse breakdown rating. It also assists in selecting an appropriate diode for the circuit. Number 3. Measure the form factor of the half-wave diode rectifier. Number 4. Measure the ripple factor of the half-wave diode rectifier. Getting started. So, let's begin. Launch Simulink and open the model we simulated in our previous lecture. Save the model. Click the drop-down menu next to the Save icon, and then click on Save As. Provide a suitable name for your model. Modify the model. Remove the voltage and current measurement blocks by selecting them and pressing the Delete button. Reconnect the circuit and remove any unconnected lines. Now, go to the Simulink library and add the necessary blocks to your workspace. From the commonly used library, add a bus selected block to your model. From the Simscape library, add a multimeter block to your model. Connect the measuring port of the diode to the bus selector. Double-click the load resistor to open its settings and enable the measurement of branch voltage and current. Connect two scopes to the two output ports of the bus selector. We will also need a demultiplexer block, so remove the mux block and replace it with a demux block. Go to Commonly Used Blocks, find the demux block, right-click on it and add it to your model. Connect the output of the multimeter to the input of the demux block, and then connect the outputs of the demux to the scopes. Double-click the bus selector block to open it. Remove the default signals, and then select the voltage and current of the diode. Click Apply, and then OK. Also, open the multimeter block and select the branch current and voltage. IB represents the branch current, and UB represents the branch voltage. Click OK. Simulate the model. Peak inverse voltage of the diode. Open the scope to observe the voltage across the diode. Go to the cursor measurements. Also, go to Signal Statistics. The minimum value shown here is the negative peak value of the diode voltage. The absolute value of this voltage is called the peak inverse voltage of the diode. So, the peak inverse voltage is 311 volts. Measure the form factor. We can determine the form factor of the half-wave diode rectifier in two ways, either from the load current or from the load voltage. Now, increase the simulation time. Next, go to the library browser, type mean in the search bar, and press Enter on your keyboard. Add both the mean block and the RMS block to your model. We will also need a divide block from the math operations section. From the sinks library, add a display block to your model. Double-click the RMS block and check the box to continuously update the RMS value at each step of the simulation. Also, open the mean block and set the frequency to 50 Hz. Connect the input of the RMS block to the load current. Let's confirm whether the first output of the multimeter is current. Yes, the first output is the branch current. Also, connect the input of the mean block to the load current. Connect the output of the RMS block to the upper input port of the divide block, and the output of the mean block to the lower input port. Click Run to start the simulation and observe the results. This is the value of the form factor for a half-wave rectifier. Rename the display block appropriately. Let's confirm the simulation result using the textbook, Power Electronics by Mohammed H. Rashid. The value matches the textbook calculation. Ripple factor calculation. Go to the library browser to add the required blocks. From Math Operations, add a math function block to your model. From commonly used blocks, add a constant block. Also add a subtract block and a square root block from Math Operations. Add a display block to show the final result. Now, connect the blocks according to the equation. Double-click the math function block and select square from the drop-down menu. Rename the display block as ripple factor. Click Run to begin the simulation. Check the output. Let's verify the result using the textbook. The value matches the calculated result from the book. We can also find form factors and ripple factors using the load voltage. Replace the load current with the load voltage and rerun the simulation. Again, we get the same values as before. Summary. In today's lesson, we performed the following tasks on a half-wave diode rectifier circuit. Number 1. We used the multimeter block to measure the circuit current and voltage across the load resistance. Number 2. We used the measuring port of the diode block to measure the peak inverse voltage of the diode. Number 3. We measured the form factor of the half-wave diode rectifier. Number 4. We measured the ripple factor of the half-wave diode rectifier. Thank you for being with us.